So, deeper dive into life science. And I'm moderating. Again, I'm Krista Sampson. I'm here with Vic Sampson, and he's going to show you a little bit about how to use the Teams platform and then go into life science.
So let's go ahead and get started. Today on this one, we wanted to do a deeper dive into the middle school life science investigations that we have in there. So we have a NGSS book that's devoted completely to life science. Here is the table of contents for that. So it includes 8 different investigations. Those are all aligned to NGSS performance expectations. If you happen to be in Texas, our books are organized by grade instead of subject matter. So in 6th grade, there are 2 life science investigations in that book. And in 7th grade, there's another 2. And in 8th grade, there's another 2. So there's life science investigations also in there. The organization is different because just the way the TEKS are set up versus the NGSS performance expectations. So for today, what we were thinking about doing, or what I was thinking about doing, is looking at photosynthesis in sunflowers from the life science book. This ends up being a very common topic that's taught in middle school, so I thought I'd show everybody how we handle that investigation. So each of our investigations start always out with a phenomenon. The idea behind this is we want kids to learn how to use science to figure out things in the world around them. So in this case, we'll have a handout that starts off talking about we see plants around us all the time. However, we rarely get a chance to see what happens when a plant is grown in the absence of light. So we're going to show a quick video about what that ends up looking like. They watch the video, and then from there, they're introduced to a task and a guiding question. From that guiding question, we asked them to share how they think they would answer that right now by developing a model to kind of share their ideas about that they have. And then they share those ideas with the other folks in their group. And then that leads to a bunch of other questions because they'll be unsure about lots of things related to their model. A lot of, I think this is what happens, but I'm not sure. So those new questions then create a need to learn all of the content that we really want the students to learn through this investigation. To make this easier for everybody to use, each of our books come with a book code that if you go to our Learning Hub, which is at adilearninghub.com, you can create a free account as a teacher. It's just your name and your email address. And you take the book code that came with your book and you enter that. And once you enter that book code, then you get access to all those investigations in there. So this is the photosynthesis in sunflowers investigation from the life science. And if you click on that investigation and you click on presentation mode, it'll move you through the entire investigation and create automatic slide decks for you. So you don't have to make those. So I use these all the time when I'm teaching to guide students through the investigation. So this is the same text that's at the very beginning of those handouts. So you can put this on the screen and then give students a chance to show the videos, and they're all embedded right in there. So let me show you the video from this investigation here. So kids know that plants need light. They're taught that at a very young age, but they very rarely see what happens when a plant starts to grow in the absence of light and what happens. And they're often pretty surprised that it makes it for a little while like that. So from there, once again, you can ask them what they're thinking, what they noticed, they share those out, and then we introduce the guiding question of the investigation, and then they develop a model around that. From there, then we can start introducing the ideas that are aligned with the standards that they're going to be using to help figure out that phenomenon. So the first one we introduce is just photosynthesis in general. You can see that with these ideas that we're sharing, lots of images. The text is designed to not only introduce vocabulary, but define it. So it's not that vague kind of text that we often see. And then we use these images to help explain what we're exactly talking about. What I usually do for this is I'll read this aloud, especially the first time I'm doing one of these. I'll usually point out things that might be helpful. So as I'm reading, it's like, oh, hey, make a star next to that. That's kind of interesting as they're following along. And then I have them talk in small groups and identify what they think are the most useful ideas from what they read. We share those out and then come up with a class list. So the first idea is photosynthesis. Then we talk a little bit about plant structures, where photosynthesis is happening and why that's important. So we show images of what cells look like under a microscope, as also chloroplasts, cytoplasms, all those different places. And we start talking about how chloroplasts actually can move in when there's a lot of light or not light. And see some of those pictures, they start thinking about, oh, okay, that could be kind of interesting of what's happening. And then we introduce the idea of system models, so they can actually investigate this phenomenon, right? So instead of having to grow plants, they're able to simulate the growth of plant under different conditions, more or less light, more or less carbon dioxide, more or less chloroplasts, and are able to kind of see how these affect the rates of photosynthesis. So after this part, they've got these ideas figured out. Once again, in the Learning Hub, all this text is in there, so you can have kind of a slide deck. The nice thing about this is all the images you can click on, and it brings it full screen for you. So it's really easy to show those. So often when we're using handouts and things like that, the images don't really show up well when you're copying them. So what's really nice about this is you can have a color image, you can put it up on your screen very easily and kind of point out anything that you think that's really important for them to be thinking about as they're being introduced to these ideas. And like I said, there's always a spot for them to write down their ideas that they think are most valuable. But what's nice about the Learning Hub and the presentation mode, you can have all of this on the screen where you can just say, hey, this is where you're writing stuff. This is where I want you to fill out at this point. So it's a really easy way to help move students through one of these investigations so they don't get lost. So they've got these ideas now, then we move to the plan stage. And what we want to do is introduce any materials that tools or techniques that they're going to be using during this investigation. So in this one, they happen to be using a simulation to investigate ideas around photosynthesis. So we embed that into Learning Hub so you can actually bring it full screen, click through it, kind of show kids what they can do with that. After they have a chance to see what the simulation can do, you ask them to go ahead and start planning out their investigation. On their handouts, they've got graphic organizers that allow them to start thinking about what's the question you're trying to answer, what observations or measurements do you need to collect, how are you going to collect those, and then what are you going to do with them once you have them. You'll notice on the bottom of all these proposals, there's a spot for your signature. So it's a great way to do a kind of a formative assessment here. Take a look at what students have written out or have them tell you what they're planning on doing. And then you can give them some feedback about what to improve if you need to, and then say, okay, good to go, you can get started. So it's a nice kind of checkpoint in there. Back in Learning Hub, what we then have is you can show this out loud and you can have them go to these, the simulation, which is just online for free. They type in those and then go in there and then remind them that they can go ahead and carry out their plans, record their observations on their handouts and that kind of stuff. On their handouts, once again, there's a spot for not only for them to write down notes as they're working with the simulation, but actually taking that data and then analyzing it. So making sense of it by looking at trends over time or differences between groups or relationships between variables. So we really want them to think about data being something that you collect, but you have to make sense of it to be able to answer the guiding question. So at the end of this stage, they should have an answer to the overall question that they are trying to answer in the investigation. So from there, we ask them to put together an argument to share what they figured out. We recommend that these are done on whiteboards. So on their handouts, there's a graphic that shows what to put on there and kind of define those pieces. Once students make their arguments, they can share them, talk over them, give each other feedback. And then toward the end of that stage, they can make any revisions they want to improve their argument, make it better based on those interactions. To help them keep track of those interactions, we've got a little spot there where they can write down ideas they got from other groups or good ideas they saw on other people's arguments as they were traveling around. So it's a really easy way for them to kind of keep track of everything that's going on. We also in Learning Hub include extra supports. So we've got like an image like here where when they're making their draft arguments, so you can add a little bit more if they get a little stuck about what exactly does evidence mean or what does justification of evidence mean. You can put this up there on the screen and they can use that as kind of a hint to refer to as they're working. Now that every student, every group has their argument finalized, they know what's going on. You want to bring in everybody back in whole group and talk over the ideas and the practices that they engaged in order to clear up any kind of misconceptions that might still be there for some individual students. How we recommend do that is we embedded images into the Learning Hub that you can show up on the board. So this is one of those for talking about the core ideas. So one of the core ideas is just the process of photosynthesis. So you can show this image up on the screen, and then you can ask students to use what they know about photosynthesis and plant and cell structures to explain what's actually going on in this image. So you have them talk in their small groups, they report out. If they're get any of that wrong, you can correct them, ask other groups to say what they think. But these images are designed for them to think about these the content that is tied directly to the standards they need to know. Most of the time, our investigations aren't exactly what a standard says. It's the core ideas that they're introduced to in the idea stage, and then the reflect discussion is what's in the standards that they need to know. So it's our way of making sure that kids have a need to learn these ideas. Then in terms of practices, one of the things that we are really hopeful that students get a chance to do is learn the practices of science by doing, right? So instead of reading about somebody doing the practices or watching somebody else do it on a video, they get a chance to try it out. And when they try those things out, planning, carrying out investigation, analyzing data, whatever that ends up being, they're going to make mistakes, and that's okay because that's part of the learning process. So the idea is not perfect, but instead to learn. To help that happen, you just hold this quick little discussion during the reflect stage about talking about what went well and didn't go so well. So we use these are all embedded in there for you. So first question, what things did you do during your investigation that made it scientific, right? So what did they do well on that? Have groups talk that over, share out. Then what would you have done differently to make it more scientific? This is where they start identifying things like I didn't do multiple trials, or I didn't include a control group, or I didn't include units, and I'm not sure what this is going on. All of those things they realized that they could have done better. And then finally, you ask the class to come up with future kind of rules or norms that we follow when we're doing an investigation to make sure that we are as scientific as we can. And that's where they start figuring out why it's important to do trials and think about measurement error and all of these other kinds of things. So they get really good at planning and carrying out investigation and engaging in the other practices through these kinds of discussions. Last step of the investigation, before that, then we also have this spot on their handouts where they can write down notes to we call it notes to your future you, right? So what came up during this discussion that you think you really should remember about either the content or the practices, and there's a spot for them to write that down, reflect a little bit more about what's important for them to keep in mind and a way to keep a record of it. Then finally, we had in the last stage called the report. We have each individual student write up a quick report to share what they figured out during the investigation. It's got basically 3 parts: an introduction, a method, and an argument. The introduction gives you a context for what you're studying and introduces the question of the investigation. The method says what you went about, what practices you engaged in, how you did that. And then your argument, you take what your group came for on your bigger whiteboard during the share stage, finalize, and then turn that into paragraphs. of text that you can share from that. We always include sentence starters on our handouts. You do not have to use those, but they're really helpful for the first few times that students are working on this, because a blank sheet of paper can be kind of overwhelming. Once everybody has their individual reports, you can collect all of those. So they have a draft of those. You can collect all of them together. Then you can divide your students into peer review groups. What I would recommend doing them is in groups of 3 at the middle school level. So if you have a class of 30, for example, you would have 10 groups of 3. Each group then gets a report, a draft report written by somebody outside their group, and one of these peer review guides. As a team, they read through these peer review guides and answer the questions of no, somewhat, or yes. If they say somewhat or no, they have to give feedback on what they would do to fix that. So they take about 15 minutes to do one report. You collect all of those. Then you give each group another report written by somebody outside their team, a new peer review guide. You can have a new recorder, all works out numbers wise. They do that one, another 15 minutes, then you do the third one. And after 45 minutes, every group has reviewed 3 reports, and every person in the class has had their draft report reviewed by a group of 3. So the draft reports with the peer review guide can go back to each of it individual original author. They can revise those. You can have them rewrite on sentence starters. You can have them type it. You can use a blank sheet of paper, however you want to do it at this point. But then after they're done with their final, I would recommend they turn in their draft, their final, and then the peer review guide that was filled out. Then you as the teacher can use the exact same review guide, but this time as a rubric, and it can assign points to each of these items based on a missing, approaching expectation, meets expectation, and exceeds expectations kind of scale. And then it gives you a great kind of assessment of what they all figured out and learned during this process. Now, as you're looking through these investigations, you might be going, wow, that's a lot of things to remember. How am I going to do that? Once again, we include very, very detailed lesson plans for all of these investigations. So this is the one for photosynthesis in sunflowers. So you've got an overview here, which describes what they're doing, what's the guiding question, and what they figure out. Then there's a graphic that tells you each of the stages and how you can divide those stages up over multiple days. We're usually thinking about 50-minute periods when we're writing these. So you'll notice on this picture that you'll see task and ideas can both be done in day 1 in 50 minutes. And then in day 2, you're doing plan and do stage, right? So you can kind of see how those are broken up. In terms of standards alignments for the next generation centers, you got performance expectation, the core ideas, cross-cutting concepts, practices, WIDA, language development standards, and Common Core English Language Arts. If you're in Texas, we have TEKS, practices, recurring themes, disciplinary content. We've got ELPS, and we've got the English Language Arts standards for those grades as well, all put in there. We also include things to know about the lesson. This is the information that you would focus on during the reflective discussion. So if you need a quick review of that, that's all there. We also include notes about preparation, about what you need to set up, how to do that. If you're doing a hands-on investigation, we'll include all the materials that you need to collect, or you can get a kit for that from our store. In the case of a simulation, it tells you exactly how the simulation works, how to use it, what it looks like, all pictures, makes it super simple to follow all of this. And then lastly, each activity within each stage has notes about what to do, what to give out, what to show. So this is the first 2 activities of the task stage. And you can see there's about 10 minutes for these 2 activities. It gives a suggestion of what to do, what to hand out for the students, what to show in the Learning Hub. It gives extra teaching tips for management. And also we focus on, in the attendant to equity boxes, things that you can do to support students that have special needs or are struggling in reading or learning a new language. So we add little hints and tips for you to do that as well. The hope behind this is not a script to follow, but gives a good example. We write this usually as how we would do it the very first time we're coming into a classroom to guest teach. So it gives a nice detailed piece of information like that for you that you can use. So with that, that's kind of the deep dive into a investigation for life science. We'll be talking about physical science from 4:30 to 5 o'clock. So if you want to join us for another session and kind of see another investigation, feel free to jump on. That's today. Tomorrow, oh no, sorry, next week, starting on Monday, we are going to be moving to middle school Earth and Space Science. So that'll be kind of the, so we that point we've done the middle school. That's at 4 to 4:30, and then 4:30 to 5 we start on high school on Monday. So we'll be doing high school Earth and Space Science in the afternoon on that. So hopefully you can join us for some of those deeper dives.
Awesome. Thanks so much for being here. Have a great afternoon.